class is in session. So today we're gonna talk about the first of a few videos I'm going to make. Originally I was gonna make this all one video, but I realized one of the things with fractions is that sometimes when we have a whole bunch of information about fractions all at once, it kind of makes it worse. So today we're just gonna focus on the first part, which is simplifying fractions. And I'm going to teach you simplifying fractions with a method that I think will make it a lot easier. And that's using a method called prime factorization. So the first thing I'm going to do is I'm going to take these two numbers that I have, 35 and 82, and I'm going to show you what I mean by prime factorization. And then I'm going to help you guys apply that to the fraction simplification. Now, this is going to be a slightly different method than what we usually do in schools, but I think it's something that if it makes sense to you, it's going to help you a lot. So first, prime factorization is when you take a number and you break it down into its prime factors. So it'll be few numbers multiplied together to get that number. And the way I like to do prime factorization is with a factor tree. So I'm gonna change the 35, well, to a 45. So what we do with these is there's a few ways to get it taken care of. Is we take a look at our number and we see what factors we think of right off the bat. So with 45 it ends at a 5. So the first thing I think of is 5. And 45 is 5 times 9. 5 is a prime number. Remember, prime numbers are when it is only multiple by 1 in itself, and 5 can only be 1 and 5. But 9 can be broken down more. 9 is 3 and 3. So when you get to the end of your factors, that list of numbers is your factor tree, or your prime factorization. So 45, and typically when we do this, we write this with the smallest numbers going to the biggest numbers. So we would do 3 times 3 times 5, and that's the prime factorization of 45. Because 3 is prime, and 5 is prime. With 82, we would do the same thing. So 82 can be broken down into 2 and I think I messed this one up. You know what? We'll change it. So once again, I'm gonna make a quick change in here. We're gonna make it 80, just 80. So 80 would be 2 times 40. That 2 is prime, it's all done. 40, we could do 4 and 10. And when you're doing factor trees, especially with a number like 80 that has so many different combinations, the order doesn't matter. So if you were to try this yourself and you pick the numbers or the factors in a different order, as long as you have the same thing at the end, you're good. So 4 is 2 times 2, and 10 is 2 times 5. So there's all our prime numbers, so a lot of 2's here, with 4 of them. So this would be the prime factorization for 80. And that's actually going to help us a little bit. I'm going to take advantage of the fact that I used the 80 here. So with simplifying fractions, the goal is to get rid of the similar factors. So we do that usually by dividing. And technically what I'm showing you is going to be related to dividing as well. But what we're going to do is we're going to take the numbers in the fractions and break them up into their prime factors. And when we break them into their prime factors, we're going to see that in the top and bottom, there are going to be some numbers in common. And if they're in common, we can eliminate them. The elimination that happens is actually dividing to 1. So 14 Let's go off to the side here. 14 is 2 times 7. And that would be the end there. So that becomes 2 times 7. And 22 is 2 times 11. That also would be it. 11 is prime. So this leaves us with 2 times 7 for the 14, 2 times 11 for the 22. So you'll see in the top and bottom we have a 2. And since we have the same thing at the top and the same thing in the bottom for that, they can cross out or cancel out. And you'll hear that term a lot. But when we have the fractions, when we have things crossing out and canceling out, they're dividing. Remember, because fractions represent the division symbol, related to division, they divide to 1. Because 2 divided by 2, anything divided by itself, is 1. So that leaves, though, 7 over 11 as our simplified fraction. So let's do this again. But this time we're going to use 25 and 60. The 25 will be easy. Let's see. I just put a space. Let's do this. Yeah. So 25 breaks down into 5 times 5. And 60 in here. 60 we can do 6 times 10. 6 is 2 times 3. And 10 is 2 times 5. So 60's prime factor, well, it would be 2 times 2 times 3 times 5. And then this also is going to take us to an additional step. So you'll see in the top and bottom we have a 5. We can cancel those out. And then we still have 2 times 2 times 3. So the last step for this, though, would be we have to put that bottom one, because there's multiple things, and then we have to put that back together. So we have 5 over 2 times 2 is 4. And 4 times 3 is 12. So 5 over 12 would be the simplified fraction here. And then I hinted at this earlier. I'm gonna steal my example. So in my example earlier, I already did 80. So we already know from the earlier example that 80 is gonna be 2 times 2, 4 times, and then a 5. But then the 418 is really big. So I'm gonna do that over here. Alright, so 418, right off the bat, I can do 2 times 209. And I don't know 209's factors, so we're gonna just use our calculator. 209 is divisible by 11. It's 11 times 19. 11 and 19 are both prime. 11 and 19 are both prime. So the top would be 2 times 11 times 19. The bottom, that would be 2 times 2 times 2 times 5. Remember, I did that earlier in a different example. So this one, even though we had some really big numbers, it actually doesn't simplify that much. The only thing they have in common is a pair of 2's. So in the top, we're still left with the 11 and the 19. And in the bottom, we're left with 3 2's and a 5. So 11 times 19 is 209. 2 times 2 is 4. Times 2 is 8. And then 8 times 5 is 40. So this prime factorization, if you make that factor tree and break up your numbers, then all you have to do is cross out the things in common, and then you can multiply everything back together. This method can take a little bit longer, but if you're a visual learner, it can definitely make things a little bit easier. So hopefully this was helpful, and hopefully I was able to make fractions a lot simpler for you. See you all next time.